Langchain prompty core front matter. A framework for building and effectively using prompts with large language models. This framework simplifies the process of crafting prompts that are tailored to specific tasks and ensure efficient communication with LLMs. It emphasizes a structured approach to prompt design, considering various aspects such as input types, desired output formats, and fine-tuning parameters. Inputs. User input refers to the raw text provided by the user to initiate a task or conversation with the LLM. This could be a question, a command, or a creative prompt. Contextual information represents any additional data or knowledge that is relevant to the user's request. It can be in the form of text, code, or other structured data that helps the LLM understand the context and generate more accurate responses. Outputs. Formatted text is the output generated by the LLM in a human-readable format, like a paragraph, a list, or a table. The format depends on the prompt structure and the specific task being performed by the LLM. Structured data refers to the output produced by the LLM in a structured format, such as JSON, CSV, or XML. This output is suitable for automated processing or further analysis. Steps. Define the prompt structure involves outlining the specific format and organization of the prompt. This includes specifying the type of information required from the user, the desired output format, and any specific instructions for the LLM. Specify input and output formats involves defining the data types and expected format of both the input provided to the LLM and the output generated by it. This helps ensure consistent data flow and facilitates communication between the user and the LLM. Craft the prompt template involves building a structured template that guides the LLM in understanding the user's request. This template includes placeholders for user inputs and specific instructions for the LLM. Fine-tune parameters refers to adjusting the settings and parameters of the LLM to optimize its behavior and output quality. This includes modifying parameters like temperature, top P, and max tokens to fine-tune the LLM's responses based on the specific task and context. Evaluate and iterate involves assessing the performance of the prompt and the LLM's output, and making necessary adjustments to the prompt structure, parameters, or training data. This iterative process helps improve the effectiveness and accuracy of the prompt and the LLM's responses. Prerequisites. Basic understanding of LLM refers to knowledge of large language models, their capabilities, and how they work. This includes understanding the basics of natural language processing, text generation, and the different types of LLMs available, such as GPT-3. GPT-3 is a powerful language model developed by OpenAI that can generate human-quality text, translate languages, write different kinds of creative content, and answer your questions in an informative way. OpenAI is a leading research and deployment company focused on artificial intelligence, with a mission to ensure that artificial general intelligence benefits all of humanity. Text generation is a core capability of LLMs, allowing them to produce coherent and contextually relevant text based on given inputs and prompts. For example, an LLM can be used to generate summaries of articles, create creative stories, or write code in different programming languages. Familiarity with prompt engineering refers to the ability to design effective prompts that guide the LLM to produce desired outputs. This involves understanding prompt design principles, exploring different prompt structures, and iteratively refining prompts based on feedback. Prompt design involves carefully crafting prompts that are clear, specific, and tailored to the desired output. This includes specifying the task, the context, and any constraints or requirements for the LLM's response. For example, a prompt for writing a poem could specify the theme, rhyme scheme, and tone of the poem. Prompt engineering is the art of creating and refining prompts to effectively interact with large language models. It involves a combination of understanding the capabilities of the LLM, designing effective prompt structures, and iteratively testing and refining prompts to improve the quality of the generated text. Fine-tune parameters. Temperature is a parameter that controls the randomness and creativity of the LLM's output. A higher temperature value leads to more unpredictable and creative outputs, while a lower value produces more predictable and deterministic responses. Top-P refers to a probability sampling technique used to control the diversity and predictability of the LLM's output. By setting a specific value for top-P, the LLM only considers a subset of the most likely words, making the output more focused and less prone to unexpected or irrelevant words. Max tokens refers to the maximum number of tokens that the LLM is allowed to generate for a given prompt. This parameter helps control the length of the output and prevents the LLM from generating overly verbose or repetitive responses. Challenges and fixes. Prompt ambiguity refers to the situation where the prompt is unclear or ambiguous, leading to the LLM producing inaccurate or irrelevant responses. This can occur due to unclear instructions, lack of context, or confusing phrasing. Clarify prompt instructions involves making the instructions in the prompt clear and specific, ensuring that the LLM fully understands the desired task. This can involve providing detailed instructions, breaking down complex tasks into simpler steps, and using concise and unambiguous language. Provide context refers to supplying the LLM with relevant information that helps it understand the task and generate more accurate responses. This can include background information, relevant data points, or examples of desired output. Providing context helps the LLM to better interpret the prompt and produce more relevant results. Unclear output format refers to the situation where the desired output format is not explicitly defined in the prompt, leading to the LLM generating responses that are not in the desired format. Specify desired output format involves explicitly defining the desired format of the output in a prompt, such as a list, a paragraph, or a table. This helps ensure that the LLM produces output that meets the user's expectations and is easy to understand and use. Use structured prompts refers to using prompts that are structured to guide the LLM to produce output in the desired format. This can involve using specific keywords or commands, or providing templates that define the structure of the output. Overfitting to training data refers to the situation where the LLM becomes overly specialized on the training data and produces responses that are biased towards the specific examples it has seen. This can lead to the LLM generating inaccurate or irrelevant responses when presented with new or unseen data. Use diverse training data involves training the LLM on a diverse range of data that covers a variety of topics and perspectives. This helps the LLM develop a more general understanding of the language and avoids overfitting to specific examples in the training data. Regularization techniques are methods used to prevent overfitting by penalizing complex models and encouraging simpler models that generalize better to unseen data. These techniques include L1 and L2 regularization, which add penalties to the model's parameters based on their magnitude. Bias in generated text refers to the situation where the LLM generates text that reflects biases. present in the training data. This can lead to the generation of text that is discriminatory, offensive, or inaccurate. Use diverse training data involves training the LLM on a diverse range of data that reflects different viewpoints and perspectives. This helps to mitigate biases present in the training data and encourages the LLM to generate more inclusive and unbiased text. Debiasing techniques are methods used to identify and mitigate biases in the LLM's output. These techniques can involve filtering biased training data, adding counterexamples to the training data, or using algorithms that specifically target and reduce bias in the generated text. Langchain prompty or prompty summarization. A comprehensive overview of prompty, a tool designed for the creation and management of prompts, highlighting its purpose, capabilities, and key features. Inputs: the raw data that feeds into the prompt generation process. This could include text, code, or any other type of information relevant to the prompt's purpose. For example, if you are building a prompt for summarizing a news article, the input data would be the article itself. User-provided inputs, such as specific instructions, parameters, or constraints that should be considered during prompt generation. These inputs allow for customization and control over the final prompt. For instance, a user might specify the desired length of the summary or the specific aspects of the text they want the prompt to focus on. Outputs: formatted prompts, structured and ready to be used with language models. This includes properly formatted instructions, placeholders for input data, and any other elements necessary for effective communication with the model. Prompt variations, providing multiple ways to express the same intent. These variations help to ensure that the language model understands the prompt's objective and can produce more accurate and diverse responses. Steps: defining the prompt template, which serves as the blueprint for the prompt generation process. This involves specifying the desired format, structure, and components of the prompt. For example, a prompt template for summarizing a text might include placeholders for the text itself, the desired length of the summary, and any specific keywords to focus on. Generating prompt variations based on the defined template and user inputs. This step involves applying different techniques, such as adding or removing instructions, rearranging elements, or adjusting parameters to create a diverse set of prompts that accurately capture the intended intent. Prerequisites: langchain, a Python library that provides a framework for working with language models. Langchain simplifies the process of interacting with these models, enabling developers to easily integrate them into their applications. This library offers a wide range of tools and utilities for handling tasks such as prompt engineering, model selection, and result interpretation. Python, a versatile and widely used programming language. Python's simple syntax, extensive libraries, and rich ecosystem make it an ideal choice for developing applications that utilize language models. Fine-tune parameters. Prompt template, allowing for customization and refinement of the prompt structure. This includes adjusting placeholders, adding or removing instructions, and modifying the overall layout of the prompt. Prompt variations, enabling fine-tuning the diversity and quality of generated prompts. This involves adjusting techniques used for generating variations, such as the number of variations to create or the specific parameters to manipulate. Challenges and fixes. Handling complex prompts, which may involve multiple instructions, conditional logic, or nested structures. Addressing this challenge involves incorporating functions and conditionals within the prompt template. allowing for more sophisticated and dynamic prompt generation. For example, a prompt might include a function to determine the length of a summary based on the input text, or a conditional statement to adjust the prompt based on the user's desired style. Generating diverse prompts. To ensure that the language model receives a wide range of perspectives and instructions. This involves utilizing different techniques and parameters during prompt variation generation. Techniques like paraphrasing, reordering elements, or adjusting tone can help create a diverse set of prompts, reducing the chances of the model producing biased or repetitive responses. Langchain prompty or NoOpParser summary. Description of inputs. The NoOpParser does not require any input. It's a pass-through parser, meaning it doesn't process the input in any way. This is useful when you need a parser that simply acts as a placeholder or doesn't need to manipulate the data. Description of outputs. The NoOpParser doesn't produce any output. It doesn't modify the input in any way. So the output is identical to the input. This means the input is passed through without any changes. Description of steps. The NoOpParser doesn't involve any parsing operations. Unlike other parsers that analyze and transform data, the NoOpParser simply accepts the input and delivers it without modification. Description of prerequisites. The NoOpParser doesn't have any prerequisites. It can be used independently without needing any specific setup or configurations. This makes it convenient to use in different scenarios without having to fulfill any external dependencies. Description of fine-tune parameters. The NoOpParser doesn't have any fine-tuning parameters. This means its behavior is fixed and can't be adjusted to adapt to specific data types or formats. It consistently passes the input without any modifications. Description of challenges and fixes. The NoOpParser doesn't present any challenges. Its simplicity makes it easy to integrate into various projects without requiring complex configurations or handling of potential issues. It acts as a straightforward pass-through element in the parsing pipeline. Langchain prompty or simple model. Langchain prompty or simple model. Langchain prompty or simple model is a foundational model within the Langchain prompty core library. It serves as a building block for creating various applications that leverage large language models. LLMs. This model provides a streamlined interface for interacting with LLMs, allowing developers to easily integrate them into their projects. Inputs. The input text is the textual data that the model processes. It can be a question, a prompt, a piece of text for summarization, or any other type of textual input that the model is designed to handle. For instance, a user might input a question like "What is the capital of France?" or a text like "The quick brown fox jumps over the lazy dog" for summarization. Model parameters are settings that control the behavior of the LLM. These parameters can include the temperature, which affects the randomness of the model's output, the top K or top P values for sampling tokens, and the maximum length of the generated text. By adjusting these parameters, developers can fine-tune the model's responses to achieve desired outcomes. Outputs. The output text is the response generated by the LLM. It represents the model's interpretation and processing of the input text. The output can be a direct answer to a question, a summary of the input text, a creative text generation, or any other type of text that the model is capable of producing. Steps. Initialization of the simple model involves setting up the model with the necessary configurations and parameters. This step might include loading the model's weights, setting up the input and output pipelines, and preparing the model for processing. Inputting the text into the model involves feeding the input text into the model's processing pipeline. This step ensures that the input text is properly formatted and ready for analysis by the model. Processing the text in the model involves applying the LLM's algorithms to the input text. This step might include tokenization, embedding, and sequence generation. The LLM uses its trained knowledge and understanding of language to generate a meaningful output. Returning the output text involves providing the model's generated response to the user or application. This step typically involves formatting the output text into a human-readable format and ensuring that it is consistent with the expected output of the application. Prerequisites. The installation of the langchain prompty core library is a fundamental requirement. This library provides the necessary functions and classes to interact with the simple model and other langchain prompty core components. The installation can be achieved using the pip package manager, as indicated by the command pip install langchain prompty core. An LLM application programming interface API key is essential for accessing and utilizing the LLM. The API key acts as a unique identifier that grants access to the LLM service and allows developers to use its capabilities. For example, a user might obtain an API key from a cloud service provider like Google Cloud AI Platform or OpenAI, which provides access to their LLMs. Fine-tune parameters. The model type refers to the specific LLM architecture being used. This can include transformer-based models like BERT, GPT-3, or other advanced language models. The choice of model type depends on the specific requirements of the application and the desired trade-off between performance, accuracy, and computational resources. The model size represents the complexity and capacity of the LLM. Larger models typically have more parameters, resulting in greater accuracy and ability to handle complex language tasks. However, larger models require more computational resources and might be slower to process. Smaller models offer a balance between performance and resource consumption. For instance, a user might choose a smaller model for real-time applications where speed is crucial, while a larger model might be preferred for tasks that require high accuracy. Challenges and fixes. The model might not be able to handle all types of input effectively. This limitation can arise when the input text falls outside the model's training data or when the input is poorly formatted or ambiguous. To address this challenge, developers can try using a different model that is better suited to the specific type of input. This might involve selecting a model that has been trained on a dataset that aligns with the input domain or using a model that has been fine-tuned for the specific task. The model might not be able to produce the desired output. This can occur when the model is not trained sufficiently for the task, when the parameters are not optimally configured, or when the input is ambiguous or lacking context. A possible fix involves fine-tuning the model on a relevant dataset. This process involves training the model on a set of data that is representative of the desired output. Another approach is to modify the model parameters to adjust its behavior and improve its ability to generate the desired output. The model might exhibit slow performance. This challenge can arise when the model is large and requires significant computational resources. One approach to address this challenge is to use a smaller model, which can result in faster processing times. Alternatively, developers can utilize a more powerful machine with greater processing capacity to handle the computational demands of the model. This might involve upgrading the hardware, using cloud computing resources, or optimizing the code for better efficiency. Langchain prompty core template settings summarization. This describes a simple model that can be used for both understanding and generating language. This model will take text input and produce text output based on the given text input. The model will also give a confidence score to determine the strength of the model's understanding of the input. Inputs: the text that is given as input for the model. This text will be processed and used to generate the output text. The input can be a single sentence, a paragraph, or even a longer text document. Additional information can be provided that gives the model context. This can be helpful for the model to generate more relevant or accurate output. The context can be a variety of different information like keywords, phrases, or entire documents. Outputs: this is the text generated by the model based on the input text and any additional context provided. The output text is what the model interprets and understands the input text to be. This is a measure of how confident the model is that its generated text is an accurate representation of the input text. The confidence score ranges from 0 to 1, where a higher score indicates a higher level of confidence in the model's output. Steps: the input text is broken down into individual units called tokens. This step is required to allow the model to process the text and understand its meaning. Tokens are often individual words or punctuation marks, but can also be larger units like phrases or sentences. The tokens are encoded into a numerical representation that the model can understand. This numerical representation allows the model to process and analyze the input text. The encoding is typically a numerical vector representing each token. The model generates the output text based on the encoded input tokens and the model's internal parameters. This step involves predicting the next token in a sequence based on the previous tokens in the input text. The generated text is decoded from the numerical representation back to text. This step takes the numerical representation of the output tokens and converts them back into human-readable text. Prerequisites: a trained language model is required to generate the output text. Examples of these models include GPT-3, BERT, and others. These models are trained on massive datasets of text and learn to understand the relationships between words and phrases. A tokenizer is required for the model to process the text input. Examples of these tokenizers include word piece tokenizer and sentence piece tokenizer. Tokenizers break down the input text into individual tokens that are then encoded into a numerical representation. Fine-tune parameters. This parameter determines how much the model's weights are updated during the training process. It controls how quickly the model learns from the data. This parameter determines the number of training examples that are processed at once during the training process. Larger batch sizes can speed up the training process, but may also lead to overfitting. Challenges and fixes. Overfitting is a problem that occurs when the model learns the training data too well and becomes unable to generalize to new data. This can be addressed by using techniques like early stopping and regularization. Techniques. Early stopping is used to stop the training process before the model starts to overfit. Regularization techniques are used to penalize the model for being too complex, which can help to prevent overfitting. Low accuracy is a problem that occurs when the model is not able to generate accurate and relevant output. This can be addressed by increasing the amount of training data used to train the model and fine-tuning the hyperparameters of the model. Increasing the amount of training data can help the model to learn more about the language and generate more accurate output. Fine-tuning the hyperparameters can help to improve the performance of the model on the task at hand. Langchain prompty param hoisting. Langchain prompty param hoisting is a technique to make your prompts more concise and readable by moving parameters outside of the main prompt body. This allows for cleaner separation of concerns within your prompts and enhances their reusability. Inputs. Input prompt refers to the original prompt that you would like to modify using parameter hoisting. Input parameters represent the values that you intend to pass into your prompt. These parameters can include things like specific information, context, or instructions that need to be dynamically injected into the prompt. Outputs. Output prompt is the modified prompt after applying parameter hoisting. It will contain placeholders representing the parameters. Output parameters are the dictionary or structure that holds the actual values for the parameters. They are used to populate the placeholders in the output prompt. Steps. Identify parameters within your prompt. This involves recognizing any variables, placeholders, or dynamic values that are used within the prompt. Define a separate parameter dictionary. This dictionary will store the names and corresponding values of the parameters identified in the previous step. Substitute parameter references with placeholders in your prompt. Replace each parameter with a designated placeholder within the prompt. This placeholder will later be populated with the actual value from the parameter dictionary. Pass the parameter dictionary alongside your prompt. This ensures that the values for the parameters are available when executing the prompt. Prerequisites. Understanding of prompt engineering concepts. This involves understanding how to construct effective prompts for language models, including the use of prompts for various tasks like text generation, translation, or question answering. Familiarity with LangChain's prompt templating capabilities. LangChain provides a powerful framework for working with prompts and supports features like parameterized prompts and templates, fine-tune parameters, parameter naming and organization. Choose clear and descriptive names for your parameters and organize them in a logical manner. This makes it easier to understand and manage the parameters. For example, instead of using param1 and param2, consider names like user query and context. Prompt structure and clarity. Ensure that the prompt structure is well defined and easy to understand. This helps with readability and maintainability. Use consistent formatting and indentation for the prompt. Challenges and fixes. Overly complex parameter structures. Avoid using nested structures or complex relationships between parameters. Aim for simplicity and clarity. Simplify parameter organization. Break down complex parameter structures into smaller, more manageable parts. Avoid unnecessary nesting or complicated relationships. Incorrect parameter references. Ensure that the placeholders in your prompt accurately correspond to the keys in your parameter dictionary. Otherwise, the wrong values will be substituted. Ensure accurate parameter mapping. Carefully verify that the placeholders in your prompt match the keys in your parameter dictionary. Use tools like debuggers or logging to track parameter references and ensure accuracy. Lack of documentation for parameters. Provide clear descriptions for each parameter in your dictionary. This helps others understand how to use the parameters correctly. Provide clear descriptions for parameters. Include documentation explaining the purpose, data type, and expected values for each parameter. This documentation can be included as comments within your code or as a separate document. LangChain prompty property settings. LangChain prompty property settings is a component in a larger language processing system that allows you to customize the behavior of the language model by providing specific instructions and preferences. This component allows for fine-grained control over how the language model generates text, ensuring it aligns with your desired outcomes. Inputs. Input prompt is the initial text you provide to the system. It serves as the starting point for the language model to understand the context and generate the desired output. An example could be write a poem about a cat. Property settings are a set of parameters that define the specific instructions and preferences you want to apply to the language model. These settings can include things like the tone of the output, the length of the response, and the desired style or format. For example, a property setting for the above prompt could be tone funny or format rhyming couplets. Outputs. Output prompt is the final text generated by the language model after processing the input prompt and applying the property settings. This output can be a poem, a story, a code snippet, or any other form of text based on the provided instructions. For example, the output for the above prompt with the property settings tone funny and format rhyming couplets could be a funny poem about a cat written in rhyming couplets. Steps. Extract property settings refers to the process of identifying and extracting the specific property settings from the input prompt. This step involves recognizing and parsing the settings provided by the user to ensure they are properly understood by the system. Process property settings involves applying the extracted property settings to the language model. This step involves modifying the model's behavior and parameters based on the provided instructions to ensure it generates the desired output. For example, if the property setting is tone funny, the language model will be adjusted to generate text with a humorous tone. Prerequisites. LangChain is a powerful library that provides a framework for building and deploying language models. It offers various tools and components to connect different language models, data sources, and applications for efficient and effective language processing tasks. This particular LangChain prompty core property settings component requires the LangChain library. LangChain 0.0.202 or above refers to the specific version of the LangChain library required for this component to function correctly. This version number ensures that the component is compatible with the latest features and functionalities of the LangChain library, enabling seamless integration and optimal performance. Prompty is a library that provides a user-friendly interface for interacting with language models. It simplifies the process of configuring and executing language models, allowing developers and users to easily define and modify the behavior of the models through intuitive prompts and settings. This component requires the Prompty library. Prompty 0.0.20 or above refers to the specific version of the Prompty library required for this component to function correctly. This version number ensures that the component is compatible with the latest features and functionalities of the Prompty library, allowing for efficient and effective interaction with the language model. Fine-tune parameters. Temperature is a parameter that controls the randomness and creativity of the language model. Higher temperatures lead to more unpredictable and diverse outputs, while lower temperatures produce more consistent and predictable results. For example, a higher temperature might generate more unexpected and creative phrases, while a lower temperature might focus on more straightforward and predictable sentences. Top P is a parameter that controls the probability distribution of the language model's output. It defines the probability threshold for selecting the next word in the generated text, allowing for the control of the model's diversity and coherence. A higher top P value will allow for a broader range of possible words. while a lower value will restrict the selection to a smaller set of highly probable words, leading to more consistent and coherent outputs. Challenges and fixes. Incorrect property settings format refers to a situation where the property settings provided by the user are not in the correct format or syntax expected by the system. This could lead to errors in interpreting and processing the instructions, resulting in unexpected or incorrect outputs. Check the format of the input property settings refers to the first step in troubleshooting incorrect property settings. It involves carefully reviewing the provided settings to identify any errors in syntax or structure, ensuring they comply with the expected format for the system. This could involve ensuring that the settings are properly separated, using the correct punctuation, and adhering to the defined format conventions. Missing property settings refers to a situation where the provided property settings are incomplete, lacking some crucial instructions or parameters that are required for the system to function correctly. This could lead to incomplete or inaccurate outputs, as the language model may lack the necessary information to generate the desired text. Provide complete property settings to avoid issues refers to the solution for the missing property settings challenge. It emphasizes the importance of providing all the necessary settings and parameters to ensure that the language model has the complete instructions required to generate the desired output. This involves carefully reviewing the list of expected settings and ensuring that all the required parameters are included in the provided property settings. LangChain Postgres Vector Stores PG Vector Summary. A comprehensive description of the LangChain PostgreSQL vector store using the PG vector extension. This description details how the system stores and retrieves embeddings within a PostgreSQL database using the PG vector extension for efficient similarity search. Inputs: text data that needs to be converted into numerical representations, also known as embeddings. These embeddings can be generated using a variety of embedding functions, and they allow for efficient comparison and retrieval of similar content. For instance, you could feed text from a news article, blog post, or product description into the system for conversion into an embedding. An embedding function, which is a mathematical model or algorithm that transforms text data into numerical vectors. These vectors capture the semantic meaning of the text. There are many popular embedding functions available, such as OpenAI's text embedding ADA002 or sentence transformers models, each with its own strengths and limitations. Outputs: the generated embeddings, stored within the PostgreSQL database using the PG vector extension. This extension provides specialized data types and indexing capabilities for working with high-dimensional vectors, making it particularly suitable for vector search applications. Retrieved embeddings based on similarity search. The system can retrieve similar embeddings from the database based on the provided query embedding. This allows you to find documents or content that is semantically similar to the input query, even if they don't share exact keywords. For example, you could search for documents that are conceptually similar to a given topic, even if the query does not explicitly mention all the relevant keywords. Steps: the process begins by initializing a PG vector object. This object is responsible for interacting with the PostgreSQL database and utilizing the PG vector extension. The initialization requires providing connection details to the database, such as the host, port, username, and password. A new table is created specifically for storing embeddings. This table is designed to handle the high-dimensional vectors generated by the embedding function. The PG vector extension provides dedicated data types for storing these vectors efficiently. The generated embeddings are then inserted into the newly created table. Each embedding is associated with a unique identifier that can be used to retrieve it later. The system performs similarity searches to retrieve embeddings that are similar to the query. Embedding. The pgvector extension provides efficient search algorithms for finding nearest neighbors based on various distance metrics. This enables retrieval of embeddings that are semantically related to the input query, even if they do not share exact keywords. Prerequisites. A PostgreSQL database must be installed on your system. This database serves as the foundation for storing and managing the embeddings. It is recommended to use a recent version of PostgreSQL for optimal performance and compatibility. The pgvector extension needs to be installed within the PostgreSQL database. This extension provides the necessary data types and functions for working with high-dimensional vectors. It enhances PostgreSQL's capabilities for vector search and similarity analysis. Database connection details are crucial for establishing communication with the PostgreSQL database. These details include the hostname or IP address of the database server, the port number, the username for accessing the database, and the corresponding password. Fine-tune parameters. The name of the table in the PostgreSQL database where the embeddings are stored. The choice of table name should be meaningful and reflect the purpose of the embeddings. It is recommended to use descriptive names to avoid confusion when managing multiple tables. The distance metric used for measuring the similarity between embeddings. Various distance metrics are available, such as Euclidean distance, cosine distance, and Manhattan distance. The choice of metric depends on the specific application and the characteristics of the embeddings. Some metrics are better suited for capturing certain types of semantic relationships than others. Challenges and fixes. Database connection errors may occur if there are issues with the provided connection details or if the PostgreSQL service is unavailable. These errors can be resolved by verifying the accuracy of the connection details, ensuring that the PostgreSQL service is running, and checking for any network connectivity problems. To resolve connection errors, it is essential to review the provided connection details carefully and confirm their accuracy. Double-check the host name, port number, username, and password. It's also important to ensure that the PostgreSQL service is running and accessible on the network. The pgvector extension might not be installed within the PostgreSQL database. In such cases, the extension needs to be installed manually to enable the necessary functionalities for working with embeddings. This usually involves downloading the extension from the pgvector repository and installing it using the appropriate PostgreSQL commands. If the pgvector extension is not installed, it can be installed by following the instructions provided in the pgvector documentation. The installation process typically involves downloading the extension package and using PostgreSQL commands to install it within the database. Performance issues during similarity search can arise due to various factors, such as inefficient PostgreSQL configuration, lack of indexing, or suboptimal database settings. Optimizing PostgreSQL configuration involves adjusting settings related to indexing, memory allocation, query planning, and other relevant parameters to enhance search performance. Consider using indexes to speed up the retrieval of similar embeddings. Additionally, tuning database settings like the number of connections, buffer pool size, and query execution plan can improve performance. To address performance issues, it is important to analyze the database configuration and identify areas for optimization. This may involve creating indexes on relevant columns, tuning the size of the buffer pool, and adjusting other database settings to improve query execution speed. The embedding function used to generate embeddings may not be compatible with pgvector's data type. This can lead to errors during the insertion or retrieval of embeddings. It is crucial to select an embedding function that produces vectors compatible with pgvector's data type. This compatibility ensures that the embeddings can be stored and retrieved correctly within a PostgreSQL database. To resolve incompatibility issues, it is essential to choose an embedding function that generates vectors compatible with the pgvector extension's data type. This may involve exploring different embedding models or modifying the output format of a embedding function to match the expected input for pgvector. Langchain prompty. Langchain create chat prompt. This prompt generates a chat prompt for use with the langchain library. It essentially creates a structured input that defines how a conversation between a user and an AI assistant should be formatted. Inputs. The desired conversation format. This specifies the structure of the dialogue between the user and the assistant. For instance, a typical format could be user assistant, where the user's input is clearly separated from a assistant's response. The desired conversation context. This provides background information, relevant details, or specific instructions for the conversation. For example, if you want the AI assistant to answer questions about a specific topic, the context could be a document or a set of facts related to that topic. Outputs. A chat prompt object. This is a structured representation of the desired conversation format and context. It can be used by langchain to initiate and manage the interaction between the user and the AI assistant. Steps. Determine the desired conversation format. This involves specifying how the user's input and the AI assistant's response will be structured. Provide the conversation context. This means supplying the relevant information or instructions needed for the conversation. Call the langchain create chat prompt function. This function takes the conversation format and context as input and returns a chat prompt object. Prerequisites. Langchain installed. Langchain is a powerful library for building and deploying language models. You need to install it before you can use the create chat prompt function. To install langchain, use the following command: pip install langchain. Basic knowledge of langchain. A basic understanding of langchain concepts is required to effectively use the create chat prompt function. Fine-tune parameters. Template. The template parameter defines the overall structure of the chat prompt. It can include placeholders for the user's input, the AI assistant's response, and other relevant information. Human prefix. This parameter specifies the prefix used to identify the user's input in the chat prompt. For example, you can use user or human as the prefix. AI prefix. This parameter specifies the prefix used to identify the AI assistant's response in the chat prompt. For example, you can use assistant or AI as the prefix. Challenges and fixes. Error: no chat prompt defined. This error occurs when the input does not specify a desired conversation format. To fix this, provide the desired conversation format in the input, such as user assistant. Error: invalid chat prompt format. This error occurs when the format of the chat prompt object is incorrect or does not adhere to the expected structure. To fix this, verify that the chat prompt object is correctly formatted and that it includes all the necessary components, such as the conversation format and context. Langchain prompty. Prompty. Langchain prompty is a tool that allows users to create and use prompts for langchain applications. It provides a user-friendly interface for defining prompts and their associated parameters. Inputs: the text of the prompt that will be used to generate the desired output. For example, a prompt for generating a creative story could be write a short story about a time traveler who goes back in time to meet their younger self. The variables that will be used as input to the prompt. These variables can be used to customize the output of the prompt. For example, a prompt for generating a poem could include input variables for the poem's subject, style, and length. Outputs: the text generated by the prompt. This text will be based on the prompt text and the input variables. For example, a prompt for generating a summary of a news article would generate a concise summary of the article's main points. Steps: define the prompt text that will be used to generate the desired output. This text should be clear, concise, and specific to the desired outcome. Define the input variables that will be used to customize the output of the prompt. These variables can be used to specify different aspects of the desired output, such as the topic, style, or length. Execute the prompt using the defined prompt text and input variables. This will generate the desired output based on the provided information. Prerequisites: langchain installation is necessary to use the langchain prompty tool. Install langchain using the following command: pip install langchain. Prompty installation is necessary to use the langchain prompty tool. Install prompty using the following command: pip install prompty. Fine-tune parameters. The prompt template can be adjusted to fine-tune the output of the prompt. For example, a prompt template could be used to specify the desired format of the output, such as a list of bullet points or a specific style of writing. The input variable types can be used to specify the type of data that each input variable should accept. For example, an input variable for a date could be defined as a date-time type, while an input variable for a name could be defined as a string type. Challenges and fixes. Handling complex prompts can be challenging when using prompts with multiple nested prompts or complex input structures. To address this, consider using nested prompts or structured input formats to simplify the prompt structure and make it easier to manage. For example, a prompt for generating a complex report could be broken down into multiple nested prompts, each responsible for generating a specific section of the report. Managing input variables can be challenging when using a large number of input variables. To address this, consider using dictionaries or custom data structures to organize the input variables and make them easier to manage. This approach can also help to avoid errors caused by typos or inconsistencies in variable names. Error handling is essential when using prompts to ensure that the tool can handle unexpected inputs or errors. To address this, implement robust error handling mechanisms that can catch and handle potential errors, preventing the tool from crashing or producing unexpected results. This might involve implementing error handling mechanisms within the prompts themselves, or by using a separate error handling library. Langchain prompty langchain. Langchain prompty langchain is a powerful tool for creating and using large language model (LLM) prompts. It provides a structured way to define prompts, their inputs, outputs, steps involved, and potential challenges and fixes. Inputs. Prompt template is a text structure that guides the LLM in generating desired output. It includes placeholders for specific inputs that will be provided during the prompt execution. For instance, a prompt template for summarizing a news article could be summarize the following news article. Article text in 5 bullet points. LLM model refers to a specific language model chosen for executing the prompt. LLMs are trained on massive amounts of text data and can generate human-like text, translate languages, write different kinds of creative content, and answer your questions in an informative way. Examples include GPT-3, Lambda, and Jurassic 1 Jumbo. Outputs. Generated text is the output produced by the LLM based on the provided prompt template and inputs. The format and content of the output depend on the specific prompt template and LLM model used. For example, if you provide a prompt to write a poem about a cat, the generated text would be a poem about a cat. Steps. Define prompt template involves crafting a well-structured text template that guides the LLM in generating the desired output. The template should include placeholders for the specific inputs that will be provided during prompt execution. Select LLM model refers to choosing a suitable LLM for the specific task at hand. Different LLMs have strengths and weaknesses, so selecting the appropriate model is crucial for achieving the desired outcome. Instantiate langchain prompt involves creating a langchain prompt object using the defined prompt template in the chosen LLM model. This object encapsulates the prompt structure and facilitates interaction with the LLM. Run prompt with LLM executes the defined prompt using the selected LLM. This involves providing the specific inputs to the prompt and receiving the generated text output from the LLM. Prerequisites. Langchain installation is essential for using langchain prompty langchain. Langchain is a framework that provides tools for building applications with LLMs. It simplifies the process of defining prompts, interacting with LLMs, and managing the workflow of LLM-powered applications. Langchain can be installed using the pip package manager, a command-line tool used to install and manage Python packages. LLM access is required to run prompts with LLMs. LLMs are typically accessed through an application programming interface API. An API is a set of definitions and protocols that allows different applications to communicate with each other. In the context of LLMs, APIs provide access to LLM capabilities such as text generation, translation, and question answering. OpenAI API key is a specific key required to access the OpenAI LLM API, which provides access to OpenAI's powerful language models such as GPT-3, GPT-4, and DAL. Fine-tune parameters. Prompt engineering refers to the process of carefully crafting and refining prompts to achieve a desired output from an LLM. This involves understanding the capabilities of the LLM, the nuances of language, and the specific requirements of the task. Effective prompt engineering can lead to more precise, accurate, and creative outputs from LLMs. LLM model selection involves choosing the most suitable LLM for the task at hand. Different LLMs have different strengths and weaknesses, so selecting the right model is crucial for achieving the desired outcome. Factors to consider include the size of the model, its training data, its capabilities, and its cost. Challenges and fixes. Prompt ambiguity arises when the prompt is unclear or open to multiple interpretations. This can lead to unexpected or irrelevant outputs from the LLM. To resolve this, refine the prompt structure by providing more specific instructions, clarifying the context, and eliminating potential ambiguity. LLM limitations refer to the inherent constraints of LLMs. LLMs are trained on massive datasets, but they are still limited in their ability to understand complex concepts, handle nuanced reasoning, and generate truly original content. To address this, Select a suitable model by choosing an LLM that is best suited for the specific task. Consider the capabilities of different LLMs and select the one that is most likely to generate the desired output. Output inconsistency occurs when the LLM produces different outputs for the same prompt. This can be caused by factors such as variations in the LLM's training data, the prompt's wording, and the context provided. To improve prompt design, carefully craft the prompt, provide clear and concise instructions, and ensure that the context is relevant to the task. Langchain prompty renderer mustache renderer summary. Inputs. The input string is a template string that may contain placeholders for variables. For example, hello, name. The input variables are a dictionary that maps variable names to their values. For example, name Alice. Outputs. The output is a rendered string where the placeholders in the template string have been replaced with the corresponding values from the input variables. For example, hello, Alice. Steps. Parser's template string. The template string is parsed to identify placeholders for variables. For example, hello, name is parsed to identify name as a variable placeholder. Substitutes variables. The variable placeholders in the template string are replaced with the corresponding values from the input variables. For example, name is replaced with Alice in the template string hello, name. To produce the rendered string hello, Alice. Prerequisites. Python installed. The Python programming language must be installed on the system. For example, using the Anaconda distribution, pip installed the Python package installer. Pip must be installed on the system. It comes bundled with the standard Python installation and is used to install additional Python packages. Mustache library installed. The Mustache templating library must be installed on the system. For example, using pip install mustache. Pip install mustache. Install the mustache library using the pip package installer. For example, pip install mustache. Fine-tune parameters. Template string format. The format of the template string can be fine-tuned to match the specific requirements of the application. For example, using a different syntax for variable placeholders or specifying a particular delimiting character. Challenges and fixes. Incorrect variable syntax. The variable placeholders in the template string may be incorrectly formatted. For example, using an incorrect syntax for the variable placeholder. Check template string for correct syntax. Verify the syntax of the template string to ensure that the variable placeholders are correctly formatted. For example, check the delimiting characters used for the variable placeholders. Missing variables. The input variables may not contain all of the variables referenced in the template string. For example, the template string may include a variable placeholder for name, but the input variables may not include the name variable. Ensure all variables are provided. Ensure that the input variables contain all of the variables referenced in the template string. For example, ensure that the input variables include a value for the name variable if the template string includes a variable placeholder for name. Langchain prompty utils. Tools designed for efficiently creating and managing prompts for interaction with large language models (LLMs), facilitating effective communication with these powerful AI systems. Inputs. User input. The user's query or request, serving as the starting point for the LLM's response generation. For example, a user might input a question about a specific topic or a creative writing prompt. Context-relevant information or background knowledge that provides context for the user input. This context helps the LLM understand the user's intent and generate more accurate and relevant responses. For example, providing a news article or a summary of a book can provide context for questions or prompts related to the content. Outputs. Generated text: the output produced by the LLM based on the user input and provided context. This can be a written response, a code snippet, a translation, or any other form of text. For example, a user might receive a detailed answer to their question or a creative story based on the prompt. LLM responses: the raw responses generated by the LLM, which may include internal reasoning steps or other information not directly displayed to the user. This can be helpful for analyzing the LLM's thought process and understanding how it arrived at its output. For example, you might see a series of reasoning steps the LLM took to answer a question, providing insights into its reasoning process. Steps. Define prompt template: creating a structured template for the prompt that outlines the desired response format and any specific information required from the LLM. For example, a prompt template for a code generation task might include placeholders for the desired programming language, code function, and specific inputs. Pass user input and context: providing the user input and relevant context to the LLM, which is then fed into the defined prompt template. This process aligns the user's query with the information needed for the LLM to generate a coherent response. For example, providing a historical event and the user's query about its significance would be fed into the prompt template. Generate text: the LLM processes the user input, context, and prompt template to generate the desired text output. This involves applying the LLM's knowledge and understanding to produce a relevant response based on the provided information. For example, the LLM might generate a paragraph summarizing the historical event based on the provided context and the user's query. Prerequisites. Langchain: a powerful library that simplifies the interaction with LLMs, providing tools for prompt creation, model management, and output processing. It acts as a bridge between the user and the LLM, enabling easy integration and manipulation of these powerful language models. Langchain Prompty: a specialized component within Langchain specifically designed for creating and managing prompts for LLMs. It offers a user-friendly interface for building complex prompts, incorporating context, and controlling the LLM's response generation process. LLM: a large language model, such as GPT 3.5 or GPT-4, trained on massive datasets to understand and generate human-like text. These powerful models can be used for a wide range of tasks, including writing, translation, code generation, and question answering. GPT-3.5: a highly capable large language model developed by OpenAI, known for its ability to generate creative and informative text. It can be used for various applications, such as writing stories, composing poems, and answering questions. GPT-4: the latest version of OpenAI's powerful large language model, known for its advanced capabilities in generating human-like text, translating languages, writing different kinds of creative content, and answering your questions in an informative way. Fine-tune parameters. Prompt template: fine-tuning the structure and content of the prompt template to improve the quality and relevance of the LLM's responses. This can involve adjusting the format, providing more specific instructions, or incorporating additional information to guide the LLM towards the desired output. For example, you might experiment with different prompt structures to elicit more creative or informative responses. LLM model: selecting and optimizing the specific LLM model used for the task. taking into account factors such as model size, training data, and capabilities. This allows for choosing the best model suited for the task at hand. Whether it requires a larger model for complex tasks or a smaller model for simpler tasks. For example, you might choose a larger model with more training data for tasks requiring advanced reasoning and knowledge, while a smaller model might be sufficient for simpler tasks like text summarization. Challenges and fixes. Prompt engineering: the art and science of designing effective prompts that guide the LLM towards generating the desired output. This involves understanding the LLM's capabilities and limitations, crafting clear and concise instructions, and providing relevant context. For example, a poorly designed prompt can lead to irrelevant or nonsensical outputs, while a well-crafted prompt can elicit specific and accurate responses. Iterative refinement: continuously refining the prompt based on feedback and experimentation to improve the quality of the LLM's responses. This involves analyzing the generated outputs, identifying areas for improvement, and making adjustments to the prompt to guide the LLM towards generating more desirable results. For example, you might experiment with different phrasings, provide additional context, or refine the structure of the prompt to elicit more insightful or creative responses. Testing and evaluation: evaluating the effectiveness of the prompt by analyzing the generated outputs and comparing them to the desired outcome. This involves assessing the quality, relevance, and accuracy of the LLM's responses, identifying any biases or errors, and making adjustments to the prompt accordingly. For example, you might test the prompt with different user inputs and evaluate the generated outputs based on their relevance, coherence, and accuracy. LLM limitations: understanding the inherent limitations of large language models, such as context window size, bias, and potential for generating incorrect or misleading information. This requires critical evaluation of the generated outputs and awareness of the potential for errors, ensuring that the LLM's responses are used responsibly and ethically. For example, while LLMs can be highly accurate, it is important to be aware that they can also generate incorrect or biased information. Context window size: the limited amount of text that an LLM can process and remember at a given time. This can restrict the ability to incorporate large amounts of context or generate responses that require a comprehensive understanding of complex information. For example, if a prompt requires information from a large body of text, the LLM may not be able to fully process all the context due to its limited window size. Prompt design optimization: designing prompts that are concise, clear, and relevant to the specific task, taking into account the LLM's context window limitations. This involves breaking down complex prompts into smaller chunks, highlighting key information, and using strategies to maximize the use of the available context. For example, you might prioritize the most relevant information in the prompt and structure it in a way that aligns with the LLM's context window. Fine-tuning: adjusting the LLM's parameters and training data to improve its performance on specific tasks, potentially increasing its accuracy and reducing bias. This involves customizing the LLM's knowledge base and capabilities to better align with the desired outputs. For example, you might fine-tune the LLM on a specific dataset related to a particular domain to improve its accuracy and expertise in that field. Chain of thought prompting: a technique for improving the LLM's reasoning abilities by prompting it to explicitly break down a problem into a series of logical steps. This can help guide the LLM towards more coherent and accurate responses. particularly for complex tasks that require reasoning and problem solving. For example, instead of directly asking for a solution to a problem, you might prompt the LLM to first outline the steps involved in solving the problem, guiding it towards a more reasoned and informed response. Langchain prompty utils execute summarization. Execute a function from the langchain prompty library. This utility allows you to leverage the functionalities provided by the langchain prompty library. Inputs. The function to execute. This represents the specific function from the langchain prompty library that you wish to utilize for your task. The arguments to pass to the function. These are the inputs required by the selected function to perform its intended operation. Outputs. The output of the function. This represents the result generated by the executed function, based on the provided inputs and the function's logic. Steps. Import the necessary libraries. This step involves importing the required modules, such as langchain prompty and potentially other libraries depending on the specific function being utilized. Create an instance of the desired function. This step involves creating an object of the selected function from the langchain prompty library, ready to be invoked. Call the function with the provided arguments. This involves executing the function with the previously specified inputs, triggering the execution of its logic. Prerequisites. Langchain prompty installed. This refers to ensuring that the langchain prompty library is installed in your Python environment, enabling access to its functions. Pip install langchain prompty. This command instructs the pip package manager to install the langchain prompty library, making it available for use. A function from langchain prompty to execute. This requires selecting a specific function from the langchain prompty library that aligns with your desired task or functionality. Fine-tune parameters. Function parameters. These are the specific settings or values that can be adjusted to fine-tune the behavior or output of the chosen function from the langchain prompty library. Challenges and fixes. Function not found. This error occurs when the specified function name does not exist within the langchain prompty library. Check the function name and ensure it exists in the library. It is crucial to verify that the function name is correct and present in the available functions within the langchain prompty library. Function arguments incorrect. This indicates that the provided inputs or arguments do not match the expected format or types required by the selected function. Verify the arguments and their types match the function's requirements. Carefully examine the function's documentation to ensure the correct types and order of arguments are used. Preventing errors during execution. Langchain prompty utils load summary. A description of the langchain prompty utils load function, which is designed to load a prompty file into the langchain framework. Inputs. The path to the prompty file, which is a text file that defines a template for generating prompts. The langchain model to be used for generating text based on the prompts. Outputs. The langchain prompt template object, which represents the loaded prompty file and can be used to generate prompts. Steps. The function first loads the prompty file from the specified path. Next, it parses the prompty file to understand the structure of the prompts. Finally, the function creates a langchain prompt template object, which encapsulates the parsed prompts and can be used to generate prompts with the specified langchain model. Prerequisites. The langchain prompty package is required to load and parse prompty files. It can be installed using the pip package manager. The langchain package is required to generate prompts and utilize the langchain model. It can also be installed using the pip package manager. Fine-tune parameters. The function does not require any fine-tuning parameters. Challenges and fixes. If an error occurs while loading the prompty file, it may be because the path provided is invalid or the file does not exist. Ensure that the path is correctly specified and the file is present in the expected location. If an error occurs while parsing the prompty file, it may be because the file format is incorrect. Check the prompty file format for any errors or inconsistencies. For example, ensure that the syntax for defining the prompts is correct.